All right, chapter 12, we are adding to chapter 3 basically, and yesterday we went back and we grabbed some concepts to remind ourselves about them. The bottom line is a plus bi, a plus bx, y hat equals a plus bx is where we stopped in chapter 3. We're going to kick it up a bit, and it's no longer going to say that, because that was just for one sample. So now for the whole population, how will this equation change according to yesterday? Do you know? Dan, did you follow yesterday what the difference is in chapter 12? It's not going to be a plus bx. What's it going to be?
It's going to be...
oh, they're in my backpack. Yeah, I have it. Do you want me to go get it?
Do you have a copy of these?
I have her okay.
You didn't give it to her?
No, I have it. It's downstairs.
So that was helpful. Dan, anything? All right. It'll be a while for you. Okay, so Kevin, we're kicking it up in chapter 12, and we're not doing just the measly one sample. What are we going to? From yesterday, huh? 2 sample. No.
You said not easily one. Y hat equals alpha plus beta x.
All right. Do you have y hat?
Sorry, mu of y.
The mean value for y is alpha plus beta x. All right, so these are statistics for a whole. I need you to be quiet so Joel can hear me and not you. When I watch these videos, sometimes you can't tell who the teacher is. So let's see. Alpha plus beta are our new statistics, and they will give us inference on A and B. In fact, this whole chapter is only going to look at one of those, and I mentioned yesterday that it's beta. So that's what we're going to do inference about. In order to do that, we're going to go by example. My only goal today is get through Weiner, so wish me luck. So Weiner is the requirements to do inference for slope. So we don't have real, we don't have RIN, we have minor. All right, to tease all the things out of our calculator, I really, really needed mine, but
Really?
oh, let's have to rely on you.
Do you need to borrow one of ours?
No, I need mine. It had all this stuff in it. All right, so we have, the first one is linear. The question is, what is linear? And that is the data itself. It has to be reasonably flowing from lower to upper or upper to lower. So let's look for the line for this data. So you can remember how to look at the line. It's a stat plot. So go to stat plot, which is what, above y equals? And go to number 1 and turn it on if it's not. And you are going to go to this selection, the one that looks like this, in this position under stat plot, and tell it L1, L2.
Second light. And then hit
and see if you can hold up the graph.
Make it say L1, L2.
You need to know, so you put you put the X in L1 and the Y in L2, so it makes sense that you should tell it L1, L2.
Right, I just...
Anyone got a picture? Yay! All right, help everyone else get that. Good?
I got this.
I'm gonna have to zoom stat it.
Yeah, I had to zoom stat.
I got it.
Zoom.
You change the...
I have to change the window. Here's.
Okay, here.
You have to zoom
got
stat it. Yeah.
Awesome. All right, that's easier than I thought. Good.
It's backwards, bro.
Good. All right. So, unless you want to graph it by hand, this is the way that you check linear. So, is there a reasonable linear flow of those data? All right. So they're not completely scattered, right?
Reasonable.
Yeah. All right.
Yeah.
So independent is next.
Let's see.
Independence does not change. So in this one we had a sample going. There were 8 people in the sample. So 8 times 10 is less than n on the test. I had some people put greater than big N. All right, don't do that. All right, it's less than the whole population. So I doubt that 80 is going to be greater than the whole population of people who wear backpacks. So, all right, so you can check that way if it's a sample, simple random sample. If not, if it's an experiment, then you have to make a statement here to say, oh, the outcome of one person's experiment will not affect the next. All right, so you've been well taught on independence. N is normal, but obviously not normal data. We just looked at the data, so we don't care about the data being normal. What we care about in Liner is the residuals being normal. So, we actually did residual plots in chapter 3, so I put a reminder on the board. First you got to find your A and B, which we did yesterday. Do you recall that?
Yep.
So remind Haley how we got our A and B for this data.
We ran a test, didn't we?
No?
Oh no, it was stat calc.
Stat calc. And we went,
it's Lin Reg.
went way down to, was it number 8?
8, Lin
Number
Reg,
eight.
yeah.
And then we hit enter.
L1, L2, and then frequency list is L5.
Okay, so I need to put something in L5?
L5 is all ones, yeah,
Okay.
See right here.
for the frequency. And then that gives you A and B.
All right, so everyone remember how do you get your A and B? All right, for a residual plot, we have to go up and highlight L3, actually way up in the margin. And we're going to use the numbers A and B and put in 16.3 plus 0.0908 times L1. That's way up in the margin of L3. So you have to actually type that out in the top.
That's 16.
Remember doing that?
Yeah.
All right. So I wrote it up here for you, right here.
Times L1, right?
Right, because that's your X value. What is here?
Is the first number 27.2?
Yeah.
I don't know.
Oh, I'm sorry. I forgot.
I got
forgot.
27.2.
Rub it in.
I'm sorry.
Where did my calculator go? It's just-
You might need to check in the computer lab, because didn't pre-calc go in there and take a test?
Do you want me to
Do you want me to see if somebody put it in Miss Stone's office like in the Lost and Found?
I mean, it was
It
in
says
here.
NCCS on the back.
Yeah, it does.
You can't really
Yeah.
take it.
Miss Stone.
Bailey.
She'll be like,
Is there something that needs to go in
Miss Stone be like,
red EQ?
It's going in my box.
it won't stop ringing.
Linear equation A plus BX. Frequency
Dang, it's gonna do a
list.
lot.
I don't recognize that. Can you show me where you got to that screen?
Is that calculator?
Oh, I'm sorry.
Alright, just store regular equation. Anyone get that question on this work here? Store regular equation.
Is that what you were saying? Did you put in 1 for the L5 and all that?
But
I was just asking her what she did.
yeah, she went down to 8.
Okay.
She went to
Try
stat
not putting
calc.
anything in.
Yeah, just see what happens.
Yeah.
So what do I do after it gives you this information?
It got A and B,
So that's
That gives you A and B.
so I didn't care about regular equation. Okay, I don't know what that is. All right, so
she
I'm
made
glad
that
you got
equation
it. So you got these numbers?
16.3.
Bailey, 16.3, 0.90. Okay, good. So now you're going to go back to stat edit and put this in. So use those numbers above L3. And did that fill in your column?
Yeah.
All right, is everyone getting the same numbers?
What did you do?
No, I don't understand.
So, okay, go
okay.
to the top of L3, like
Now we're
instead
like
of putting
L-
things in the chart, where it says L3 and just
Okay.
type it in and hit enter.
Type what in?
The
So-
equation.
For L3, you're gonna type in
Daniel, is your first number...
16.3
Miss Powell, I'm not getting
Plus
the same answers as Ken.
Is anybody's first number 27.196?
L1.
Are they the same?
And then once you hit enter,
Yeah,
it fills in that
check
one.
No,
this
mine's
out.
Then
27.1.
same thing for L4, but you're just putting in
It said error.
L2.
That's what
L1
I
all the way
did.
down. L1 all the way down.
Yeah.
Gives you that
So now we're getting
column,
the
and
same
then you
one.
just push
Do I have to put an
in.
X?
That has to be ones.
No, you
Put
need to put
ones in for
parentheses
L1.
L1.
I don't know why, but I
It's
didn't
times
have to.
L1.
You gotta tell the
Daniel, is your first number
calculator where to get
27.196?
And then right here.
29,
Yeah.
35, 31.
27.1, yeah.
Is that one that's...
Brian, you get it?
Oh, okay.
Ryan, this thing is off.
You didn't even try?
I don't know what's going on.
Okay, Ryan, look. Go to stat, edit, so where your things are. For L3, put in that... Do you remember how we got those numbers?
Yesterday we got
Right.
the numbers,
right.
A
I
and
gave you
B.
those numbers.
Yeah.
So, okay, so then you put the equation into the top row. Or
I did that again.
you put it in.
I erased L4.
Alright,
And then you're
Any
gonna
luck
do
here?
L3.
I erased L4 by accident while I was
Mine
L4 should be
Well, we
blank.
need L4 for that one.
Yeah, but I
Oh,
erased
L4 is
it.
L2 minus L3.
Okay,
Literally
now
all L4
finally
is
for the
You
residuals,
can
go up on the top of L4
Yeah, you put in a 6.
and write
Now there's
L2.
5.
So that's your observed minus, and L3 is your expected.
Is people's L4 the first digit negative 1.196?
Yes.
Okay.
Alright,
I got negative
Yeah, I
0.197.
put it there, but it's just in the wrong order.
It's not negative 1
it
point.
should be identical, but
Did anybody else get negative
1.19?
1.196?
Yes.
Yes,
Okay.
top of
I
L4.
did.
Okay.
alright.
The top of L4.
Yeah, I didn't get
Did you
that.
do L3
You might
minus
check your list,
L2
make sure
instead
you
of
put
L2 minus
everything
L3?
in
I don't
correctly.
think so.
If yours is different than ours.
Put in like a 27.
Okay, so those are your residuals. Why do we go through all that?
7 instead of
Because we have to check
Yeah,
if
even
they're
your L3 is a
normal or
little bit
not.
off.
Ah!
So,
Oh, you're not at the top.
they are lurking there in
Yeah, you were at the top.
L4.
Lurking.
You had to go back up to the. You were at the
L
bottom of the
stands
list.
for
That is the
lurking.
top of the screen.
So
you're
in
bottom.
L4, we want to go to stat plot. In fact, we want to go to the next stat plot because we're going to probably have to change the window, and we don't want to change it for a graph that we just did.
Wait, so
So
second stat plot should be
go
on?
to stat plot 1 and turn it off. We don't need that one now. And go down to stat plot 2.
So turn 1 off.
How do you
Yeah,
get
and
that?
go down to 2.
Second
And now
y equals a
go
stat
over
plot.
here and
The
select
histogram.
the histogram, but where are you going to tell it to go?
L4.
R4. Just, does it ask for frequency?
It's a, yeah, frequency.
Alright, alright.
Wait,
And
no,
will it
that's-
take one? If it'll take one, you can give it. If not, we have a little column all set up for us.
Nope.
I have to zoom stat it again.
No, just put the number 1 in there.
Can you say
I got
the
it.
calculator?
Okay.
Miss
What are we
Powell.
Let's see, now we're going to graph a histogram.
For,
Okay.
Wait, Miss Powell, can you say that?
sorry.
Let's look
Oh
at
yeah,
your
go to
window.
turn on.
I
Go
tried
to
to
stat
type in
plot
1
1.
and type
Yeah,
in
let's
one.
do
did it
X
earlier.
scale like 3. That'll
turn it off.
change it a
Put in
little bit.
L5.
Now hit enter.
Aw.
And then go to stat plot 2, turn it on, and then make it a histogram.
Yeah, can you mess? Oops.
Miss
Alright,
Powell, does it look like this?
Turn L.
That's
That's what mine
see
looks
what
like.
your scale,
mine's giving
your
me an
X
error
scale
message.
is.
Okay.
See what your X
It
scale
didn't
is.
offer me an X scale.
Ah.
like
Well,
on
you
the-
gotta-
oh, you go to the okay.
Alright, so 1.7. That's
Yeah.
a weird X scale. Let's try
Okay.
again. That means it's going further back.
I have to
It's going
put
by
it
twos,
on
right?
L5.
Yeah.
So, that
Okay,
looks a
that's
little
better, yeah.
better. I'll even try.
It doesn't look any better.
Okay.
So go
Yeah,
window
window,
scale
right.
on the X scale.
Oh.
3. See what that looks like.
Oh, that's
I
way
like the
worse,
other
yeah.
one.
Wait, what do we say for X
Data.
scale?
2 works better for your
Yeah.
X scale.
Change your X scale to 2.
Is this what it is?
To 2 or 3?
I don't know.
2. I tried 3 and it looks ugly.
Notice it's putting a weird. You want to know how many is it counting in each box. So if you go to
Oh,
window
you're
X scale.
I like how much
We found a
Barbie's in
better
it though.
picture. 1.7 is weird, so we put
They were
2.
cousins.
So it's going to group by 2 pounds.
I think
Okay, that'll do.
They were like third.
So that looks a little better. Alright, so at least when we put an X scale of 2 in there, we've got at least a value with a single peak. So it looked somewhat normal.
This
I mean, it wasn't.
Why the heck did you mess with everything else? I told you to mess with X.
Alright.
A normal line looks.
Maybe there's some
one
other
off,
stuff
plot
with the
2
window.
on.
I don't know.
Why are we doing
What do you do? What window do you
Change
have?
plot 2 on, make it a histogram.
It's put change the wedges. So I don't know. Why.
It's
Here, I'll change
Just
it.
to get it to fit in there.
I just rounded up.
Wait, does white come up on white
No, it should have been.
for a graph?
Probably.
Look,
Nope.
it's telling me this.
Look, it
yours
just
looks
erasing
really
the
Someone
line.
like to explain
Yeah, I
this.
see.
Well,
What's wrong with you?
where did you tell it?
Okay.
Were you on the
What are you trying to
second
do?
stat plot?
So right, go to stat plot
He
1,
just
turn it
changed
off.
the
Said
window.
Stat plot 2, turn it on.
L4. Said L4,
There's the
so.
histogram.
Alright,
Frequency list is L5.
alright. So,
What?
Graph.
recall that we want a normal plot for the residuals. E.
Yeah.
If you
I
were
have
left and couldn't get this graph up, I'd come by later and help you with
I
that.
come by that.
Alright, this one, we're gonna look at the residual plot. That's not
See you later.
what we just did. We're gonna look at the residual plot.
That's the dots we did. isn't
Alright,
it?
so we can go back to stat plot 1 where we were working originally with the data. Go back, turn off your stat plot 2, go back to your stat plot 1, and we're going to ask the calculator to give us just a regular old boring graph, but of the residuals.
Are we gonna give it
So
a
you're
line?
going to tell it what?
L4.
L4.
And what?
So,
L3 and L4 or
L4
L1
and
and
L5.
so what, you know, if it says frequency,
Yeah, L4
that's
and
why
L5.
we put
If it says X less
that's
than
why
Y
we
less.
put in a 1 on all those. So it'll only use every one of our data points once. So
What
go
about-
back.
L.
So if you grab
and
L4, L5, do you get
Mine is like a whole
graph?
straight line.
What is
Okay.
that?
What?
Which type of graph?
It's very straight.
That's not right.
Really?
Which type?
What is E? Does E stand for I?
Yeah, I was gonna say.
Yeah, mine's a straight line.
Mine is also a straight line.
No.
Mine's also straight.
Miss Powell, we all got straight lines.
That's
straight.
It's asking
Oh,
for a
it's
Y
straight.
list, not frequency. It's asking
I
for a
couldn't do the
Y
old ones, so
list.
there's no way I'm gonna be able to do
Okay.
this.
So
Yeah, how
let's
did we
see.
get there?
That's why I said L4.
Turn
I
plot
figured
2
all
off
this
again.
out
Bottom
on my
and bottom.
calculator.
Oh my
It's not
goodness.
helping.
Oh yeah, it's giving us a Y list, not a
Wait,
frequency.
now turn. You're
What do we
saying,
put in for Y list?
You're
Yeah.
saying turn on
Yeah,
plot
what
1
would be the
now.
Y list? The
Turn
Y
on
list will
plot
be your X values.
So L1.
L1.
Okay. Try it again.
What?
Because you're trying to get the residual at each weight.
Oh, now I ain't got nothing.
What's
Now
X?
mine's all over the
Yeah.
place.
Who's
Hello,
that?
what's X list?
Oh,
L
Jesus.
list is
Oh,
L4.
Okay.
So it's L1,
Is that right?
L4?
Holy goodness gracious.
So it should go this way.
Holy goodness
What's
gracious.
Y list?
They're all over
Does
there.
yours go
What's
that
the
way?
Y?
It looks like a
That's what I was
shotgun.
asking for. What's Y list?
L1.
It is.
No,
That's
he's
it.
not.
But mine-
He's literally not.
We want the X list.
No, it doesn't look the same.
Yeah, it does. It's just that way. Oh wait, no it
No, it
doesn't.
doesn't.
Wait, there it is. It's
So
this
make
way.
sure you're
Yes,
putting
it is.
in
No, yes, it is.
on the residual plot. Remember what we're trying to get is the value for each of these in L4 against each body weight. So are you putting in residual L4 and then a Y list?
Yes.
I guess switch
That's why it
those.
works.
I guess this is your Y. This must be your Y. That's why it's sideways.
Oh,
So
okay.
do L1, L4.
Oh, my,
Dumb.
is this supposed to look like this?
L1, L4.
That's
So
what I
That's what we got, but she's telling us to do L1 as the
So
X
mine was
list.
right. Yours was right.
No, yours is
wrong. So
the
you
wrong
got the right
way.
one.
Oh.
So switch L1 and L4 graph and that.
Put
That-
X,
That's a little
L1,
bit
and
more
Y,
lenient.
L4.
There we go, Miss Powell.
Just a little bit.
Yeah, he's got it. Let me show
I got it.
everyone.
Oh, that's
Here, Frank.
I
This is
know.
what we're looking for.
I got mine the other way.
Okay.
Switch it.
Yeah.
Wait, switch what?
Switch L1 and L4.
Okay.
Yay!
Miss Powell, you found your calculator.
What does E stand for? I think it
Miss
is.
Powell, what does E stand for?
Alright, E stands for
Eyeball it.
the eyeballs.
Is it actually? Okay. No, everybody brains. I'm gonna call it eyeballs.
Variance.
Eyeball. Eyeball variance.
So equal variance is what that actually stands for, and it means we're going to look at each x value. So let me see yours again.
What's the difference at looking at normal residuals and looking
Have
at
I
the
told you
residual
about the
plot?
NCCS piece yet?
A lot.
You gonna come? You wanna see?
I'll explain that after I get through here.
It's gonna.
All
You've seen
right.
the answer, right?
So what we're supposed to do is when we look at this residual plot, we're supposed to look at each x value, and
Nothing like that.
because we only have 8 data points, this one probably won't work very well. And we'll have to make an exception to go on. But if we look at each value for x, the number of dots above it and below it should be about equidistant. So that means equal variance, varying equally above and below that line. So I don't see a whole lot of that happening.
Yeah, mine is.
A little bit.
I was looking at your black.
But like this is this one. There's nothing down here to match. There's nothing up there to match. These are matches.
But it's still 4 on top, 4 on bottom.
Yeah, but they don't mean that. They mean for each value of x.
It is blue.
So if I were you, I'd be failing that because when I look at each value for x, say I look for this value for x, I see one dot. I don't see an equal.
Bless you.
I don't see an equal one up here.
Yeah, no.
And then if I look at this one,
So this one would fail.
yeah,
Right?
I think so. But it's hard to get E to pass when you have such small data as 8.
Man, it's gonna take
Alright.
a while to do
All right,
this.
let's finish this one. So equal variance, you pull up the residual plot and you look at it. The residual plot is plotting the body weights what do we end up? The body weight's on L1 and the residuals on the Y,
Right.
L2. Is that how it worked out?
Yeah.
L1, L4? Okay. So keep that. You might take notes on this. It's going to be hard to remember. Our last one, number R is random.
Oh, that's an easy
That's
one.
kind of like a class on how to use your calculator.
There
If you know where to get what you need to get,
Is
then
this
it's
is this
fine.
how moms feel when they first got a smartphone?
Dang.
I'm sure you went through a
Oh my
learning
gosh,
curve.
that's probably like the closest thing to
Yeah.
like to like a grandmother like getting a
Imagine a grandmother getting an Android. This is what that.
Imagine a grandmother getting one of these.
My grandmother.
Yeah, you're right. She knows
I
better
love
than
your Miss
us.
Val. Wait,
Yeah,
no,
unless
they
you're Miss
had
Val.
calculators when our grandparents were in
They didn't just.
Not like these
Fucking
computer.
TI 83
All right,
plus.
let me make a comment and you'll be free to go.
Yeah, mine's 84.
If you
Plus
would
is an
remain
84.
until I finish
Mine's
this
an
comment,
84.
just take you a minute and probably pass the bell. All right, what I'm going to do is I'm going to take the XY axis. Just watch this. We'll actually take notes on it tomorrow. The only homework will be study your cards. So I'm going to take this XY axis and I'm going to lay it down. So do you see the perspective? This is now the X and the Y. It's laying on the floor and I'm going to come up out of the floor.
Stop, don't tell me it's Z.
It's not Z.
What's
All right,
Z?
so.
Wait, how is this?
Oh, XYZ?
So just watch and enjoy. So what I'm going to do is the things that are going to come up out of this graph are going to be my Y values, and the X are going to be along here. So it turns out if we have the regression line for the whole population, that's Y, mu sub Y equals alpha plus beta X. All right, that's what we're trying to get, but say we know it. This is where it'll be, on the floor. So that's our alpha plus beta X. It is a population regression line. Just hang there 1 second. So if I go to X1, say I go to those people who weigh 120 pounds. Then the result in the whole population, there's not just one person that weighs 120 pounds. There are a gazillion people. And guess what? They all have a different backpack weight. And so here's what their distribution would look like across from X1. It would look like a normal curve. So that is all the values that are possible at 120. So we don't have just one value that comes out. We have a normal curve of values that come out. All right, so we'll pick that up tomorrow, and you'll actually sketch that on the back. You'll see a spot for that. All right, so we meet again and study your cards.